we get the recording button. Okay, so everybody's back. Welcome back. So, tell me what you remember from last time. I will accept gestures, words, letters, anything you got.
I remember how to access the page. I remember something about SAS, R, and other stat programs. Uh, I won't hog all the narrative. I'll let other people go.
That's good. So yes, you can access the page, access the icon. I did fix the links, by the way. One of you pointed out that I had some dead links already. So the handouts for getting started with the virtual desktop, by which you can access SAS software as well as Stata software and a bunch of other things. There are handouts here and there are videos here. So either one of those will work for you to try and get started with the system. By the way, I learned something after posting the videos that will help you get in faster. You know how you have to do two-factor authentication to get into the virtual network? It pops up and it wants a second password beyond just your usual Hawk ID password. I learned that you can type in push and then it will send it to your phone. So you don't have to enter like a 6-digit code or something, whatever I said in the video. My knowledge was antiquated for the system there, so that's a little bit more convenient. So yes, accessing things, accessing software. There's not a lot to do in terms of homework and whatnot at the beginning of the course, and that is on purpose because I want you to spend the time getting used to using the software, getting into the software, and following along with the videos that I made describing how to use each of the packages. And so you can choose to follow along with the SAS videos or with the Stata videos, and I've put places on the website here for days in which those would be good things for you to be working on. Okay, so thank you, Jerome. Who else wants to play? What do you remember from last time?
That we're going to get a lot of opportunities to practice how to do everything you teach us, but you haven't told us how much yet because it would be, quote, disheartening. But it's no matter what. You've assured us of that a lot of times.
Yes, that is almost a direct quote, I think. Very good. No, I'll tell you, I'm trying to remember for this class, it's somewhere around 500 questions, something like that, across the semester. So, and that's disheartening if you think of it as work, but it's also heartening if you think of it as if you screw a few up, it's fine, right? It'll be fine. Lots of opportunities. So good. That's another thing to remember. Am I going to try to scare you? Am I going to try to make you cry?
I hope not, but
No. Tiffany,
try.
no. She's like, yeah, you're going to make us cry. You're going to cry with joy. That's what you're going to cry with because you're going to think this thing that I've been afraid of or nervous about, it's going to be fine and I'm going to have tears of relief. That's what's going to happen. That's the goal. She looks skeptical. That's fine. That's fine. I know it's week one. You don't know me. You don't have to trust me yet. We'll see. We'll get there. What else? We started talking about variables.
Yeah. Could I jump back in? I guess.
Please jump in.
I also learned that group work is encouraged. We do have our individual data sets, but it's the overall learning that we're focusing on. There will not be tests, but the homework. And I remember the 88% versus the 12% as well.
Yes.
So, yeah.
Yes. Very good memory. Yeah. 88 points versus 12 points. So 88 is for homework. 12 is for formative assessments, which are just opportunities for review where you get your points if you do it. I don't grade them for accuracy. Yes, group work is fine. I know, especially it can be a way of building cohort camaraderie, so to speak, with people that you're with to work on things together. And I'm all for that, just so long as each person, when when it's over with, can do it on their own if they need to. That's the goal. Unless you plan to like work with somebody for the rest of your life, then that sort of like codependency is generally not a good strategy. So yeah. So variables. We started talking about variables. There's two main kinds.
There's categorical, which are qualitative, and numerical, which are quantitative. Categorical breaks down into nominal, which is named categories, so things like race or yes or no, and then ordinal, which is an implied order, like a Likert scale, not a Likert scale.
Also true. Yes. So in binary, nominal, and ordinal, I would say are the sort of the subcategories. Binary, you can't make a distinction as to whether it's ordered or not because there's only one difference. Whereas ordered would be like Likert scales and trying to think of other examples. Rankings. So in the Olympics, as my 5-year-old would say, you get a golden medal if you come in first, and you get a silver medal if you come in second. So we know who came in first. There's nothing about the margin of victory that's relevant there, right? It's just an ordering. Third place, by the way, is brawn. Golden, silver, and brawn. That's what you get. So let's see. And the numbers, we start talking about numeric variables. So the way that you will approach using these sorts of variables in analyses depends on whether or not they are categories or whether they're numbers. And numbers, I would say, come in either they have boundaries or they don't, right? So one example that has a boundary is a count variable, where you can't have any counts that go below 0, but you can have counts that go up to positive infinity. You can have binomial variables, which are bounded between like a 0 and a 1. You can think of rates or percentages, things like that. Or you can have numeric variables that are more continuous, or continue-ish is the word that I use for that. Things that you don't have natural boundaries as part of their measurement scale, but they may be bounded sort of in practice. Like there may be a point where you can't measure response time below that, or you don't have information on your scale above that, or something like that. So just a little bit of introductory vocabulary. All right, since we're on that note, let me get back to our friend the PowerPoints. We hit the high points. I wanted to do, turning to some new stuff now, a little bit about how to store information in data sets, because this is something that I found doesn't necessarily get taught. And I've worked with students and faculty who end up having to spend more work reconfiguring data to be able to get it into SAS or Stata or R than they would have had to do had they known a few things in advance. So I just wanted to give you a little bit of background. If you're working with beginning to create data sets, entering data, that kind of thing, what are some things to keep in mind? Does that work for you guys? Is that all right? That works? Okay. So it's not statistics, but it's sort of the important precursors to actually using the software packages to give you the answers that you want. So we'll start on, this is slide 21 of lecture 0. And so we can store data in a variety of formats. The way that I'm going to give you data to work with for your homework is in an Excel file, .xlsx. I pick that format because that way you don't have to have the programs on your computer. You can open it up. You can use, what is it, Google Spreadsheets? What is that thing called? Is that right? Something like that. There's OpenOffice. Mac has a version of spreadsheets. It doesn't have to be Excel proprietary, although you do all have Office 365 licenses that you can get. You can get all the software for free from the university if you didn't know that. So there will be, when you're doing homework, each homework assignment that I give you, I'm going to also give you, along with the data, what I call a starter file of code that will help you with the instructions to read in the data to the package. That way you don't have to recreate everything from scratch and you can just focus on the modeling per se. So you'll need to save the data set that you download into a folder, figure out where that folder is, and then take that path to the folder and you'll put it into the program. Now there's a reason I say figure out where it is, because that turns out to be non-trivial because in using the virtual desktop. In particular, those of you who have Macs instead of Windows, some of you already have an H drive, like on your computer as a hard disk. But then if you connect to the university server, it also has an H drive. So you have two different H drives, and making sure that you're pointed at the right one can be a little bit tricky. So that's partly why I made the videos, partly why I have the starter syntax to try and simplify the process of just telling the program where your data is, because that turns out to be tricky. Inside a data file, there will be 3 pieces of information that go with each column. So in these files, rows are generally cases, like individual people or individual occasions, whatever unit you're measuring, and columns tend to be variables. So at a minimum, each column needs a name, and variable names cannot start with a number. You cannot use special characters in them except for underscore. So this is the one thing that you'll have to know in order to ask the program to provide information about that variable is what is it named. And that's one of the things that I'll have in the starter file that I give you is just literally the list of variable names so that you can refer to it. You can then also add what's known as a label, which is like a title that goes with the column where you can elaborate what the column refers to. So you can give sort of an extended description of it that uses spaces. It can be up to 256 characters in most programs, and that can make your output more readable because that label will show up next to the information that you've requested for that column. And then there's also what's known as value labels. And this is a mapping of what a number means for a categorical variable. So if you have a yes/no question, you would have a mapping that says 0 is no and 1 is yes. And you provide that mapping information to the program. And then when it spits out your results, rather than it just giving you zeros and ones, it will say no and it will say yes. That way you don't have to remember what the numeric labels refer to. It makes it easier for you to digest the information and to present it to other people directly. So you'll have all 3 of these things describing each column of data when you get it from me to do homework with. And if you download like a publicly available data set, they will have all 3 of these things usually as part of that download package as well. So in terms of entering data, if you're ever in a position where you have to enter something from scratch, don't think that if you're eventually going to use SAS that you need to enter data into a SAS database. In fact, that is a bad idea. It's not meant for that purpose. I believe in Excel. I like using Excel for a lot of things, not statistics, but for managing entry data. It has freeze panes, it has split screens and things like that that can make it easier to keep track of where you are. One thing to keep in mind, though, is that Excel has a lot of formatting, right? You can bold things, you can make things red or green or whatever. None of that formatting gets transferred into the database when you import an Excel database into a stats program. So if you decide that numbers that are colored in red mean this and numbers that are colored in green mean that, that meaning is lost. So instead of doing it with formatting, you'd want to make an additional column that says which characteristic a given case falls into. So you'd make that another variable, so to speak. So formatting doesn't matter. Whatever you do to make it look nice doesn't matter. The program will take it and ignore it. So it has a nice feature, all programs do, that it understands that if you make the name of the column the first row of your Excel spreadsheet, there's a box you can check or an option you can add to read in those names as variable names directly. So that's a really useful way to save time so that you don't have to rename your columns after the fact. It's helpful to then make sure that those names correspond to allowable variable names. So no special characters except underscore. Must start with a letter instead of a number. And nowadays, most of them can be as long as you want, but just keep in mind that the longer the name is, the more typing you're going to have to do to refer to it. So a short enough name to be descriptive and not too short that you don't know what it is, like somewhere in there. It used to be that you could only have 8 characters. So you may see certain examples that stop at 8 characters because they're trying to be backwards compatible with software that doesn't allow more than 8. And last but not least, there are ways of abbreviating series of columns in these programs that you can take advantage of if you name your variables in a particular way. So if I have a questionnaire, for instance, and I have different ways of measuring, like a bunch of different items that asks about stressful experiences, I could name the column with some sort of reference to what the question means, but that would not be as useful as just saying like it's stress 1, stress 2, stress 3. And then in the label, the detailed label that's 256 characters, then you could elaborate on what the actual question was. The reason is that let's say that you want to take a sum across items. If you put the number at the end, you can abbreviate a list by saying like stress 1 dash stress 10, and it understands that you mean stress 1, stress 2, stress 3, stress 4, and so on. So you can refer to sets of columns quickly if they end in a number that you can then ask it to extrapolate across. And you can also extrapolate across positional columns too in some software packages like SAS. But that's, I think, less common. So how are we doing so far? Is any of this new information, old information?
Some of it's new to me.
Some of it's new? Okay. If you're ever in a situation where you're going to be working with some sort of data wrangling task and you're going to have to do the same thing over and over and over and over again, stop and send me an email. Because there are ways to get stats packages to do things for you in a loop, right? To do the same thing to a bunch of columns in a row or a bunch of rows in the row that you may not know about, but it will save you a lot of time. True story. I told you I grew up with SPSS. I once spent 6 weeks doing something by hand that would have been 3 lines of code. And I once had a PhD student who spent her entire summer and hired her teenage son to help her to do something in an Excel database that was 4 lines of code. So things that are repetitive, where you're trying to do the same thing to sets of data or different data sets over and over again, great candidate to learn a little bit about software to make it do it for you. So I'm happy to help troubleshoot if you're in that situation. In terms of entering data, the 2 main types that you'll come across are either numeric or what people call string or text. And I would encourage you, when at all possible, to save information in a numeric format, even for categorical variables. So if you have, say, a control group versus a treatment group, and you need to keep track of which group a given person is in, control is 0, treatment is 1. There's only one way to write a 0, right? There's not capital 0 and lowercase 0, and there's only one way to write a 1. Whereas, like if you look at this example, control group as a word would not be read as the same thing as control group with capital letters or with an extra space at the end of it. So there are a million ways that you can make typos when it comes to entering verbal labels, and that will preclude having your data be nice and organized. So if you use numbers instead, that will cut down on data entry errors. You can always tell the program after the fact through value labels what 0 means and what 1 means. So in the value labels, by the way, I typically put the numbers with them. That way I can refer back to my original coding and know what it means in the same shot. Don't mix numbers and text together. So if you're in a situation where someone was supposed to give an answer ranging between 1 to 5, and instead they made a note off to the side, don't enter that note where the numbers are supposed to go. Otherwise, it will change the entire column to be text variables, even the numbers. The best way to solve that problem is to make a new column that is a separate text column that you could add things to for those cases where people didn't follow instructions or whether they have missing data. So you'll also see missing data codes in a lot of databases where people will put like -99 if they didn't answer and -98 if they didn't get the question at all, those kinds of things. Those are not helpful because when they're mixed in with the original column, you can't use them. They become dots or NA in R. So it's much better to take reasons for missingness for a column and make that a whole separate column where the choices are present, absent for this reason, absent for that reason as a categorical variable. That will save you a lot of headache with missing data. All right, and then last but not least, levels of analysis. So I just ran into this question with an investigator who was tracking students over time. And so she had certain databases that were measured for every occasion, and then she had information that was measured only once per student. And when she asked me, how do you want the data? Like, is it okay that I have these two different types of data? I said, yes, absolutely, that is how it's supposed to be. So you can have a separate database for every level of sampling that you're collecting information over. So the only catch is that each individual unit has to have an ID. So in that case, I would have an ID for which kid it is and which occasion it is. And then I would have the kid ID in the kid level database, and then I can merge them back together. And the kid information would get pasted all the way across all the occasions for that child in the other database, which is what you would need to do to be able to use it. So don't feel like you need to have just one data set if you have multiple levels of sampling. One data set per type of sampling is a much easier way to do it. And it will be fine when you put it all back together again. How's that? Okay, now you've learned a little bit about that. Question?
I was gonna say, so are we gonna get like chances to practice throughout the semester then?
In this class, not so much. In other classes, potentially. I'm trying to spare you from the agony of data management in this course. So the most things that you would do with data is to read it in from Excel, maybe make new columns. So to recode information that's already in the data set in a different way for an analysis. But I'm staying away from sort of the tricky stuff. If you're interested in learning more about how to work with data though, I can point you to several different places. So if you want to learn R, the language R, there is a whole class about that. It's 6250. It's Computer Packages, I think is the name, is in the title. It's taught by Brandon LeBeau at least once a year. He does a lot of stuff with R in terms of managing data and reproducibility and all that kind of stuff. In EPLS, Brian On teaches a course every spring in Stata that has additional data manipulation kinds of things in it, particularly for large databases. He has some extra stuff that he teaches about that. And then last but not least, if you want to become a better SAS user, I used to teach a class at the University of Nebraska in the summer that was called Make Friends with SAS. And that material is on my website. Yeah, that's literally what I called it, because the goal was for people to not be afraid of it when they had to go and use it in a stats class. And so I have the material on my website from the last version I taught of that class, and that would be a good resource if you want to learn how to do SAS stuff. So, and if you have questions about how to do things at any time, you can ask me, and I'll either show you or say I don't know, or we'll look it up on the Google together and try to find it. So, all right. So wrapping up, our goal this semester, after we get through univariate descriptive statistics and inferential statistics this unit and bivariate, we're going to do general linear models. We're going to predict quantitative outcomes from combinations of quantitative or categorical predictors. And if you want to learn how to predict other kinds of outcomes, so things that are not continue-ish but are either bounded or categorical, you got to come to a different class. Oh, and one more other thing we didn't talk about that we did last time, sampling. Remember we talked a little bit about sampling? independent versus dependent samples. The stuff I'm going to teach you in this class is designed for data in which there there's one observation per person, and people are supposed to be independent. If that is not the case, then everything that you're going to learn has to have some extra stuff attached to it in order to use it for dependent samples. And that's my other courses in what's known as multi-level modeling, which is when you have more than one observation per sampling unit, broadly construed. So, good. Questions on lecture 0 before we change gears into lecture 1?